Good morning. So last lesson, we started a project together so that we can look at the computational methods, all of the things that you need to be aware of to prove that your project is solvable. And we started putting together a project for pathfinding algorithms. We shared a link on GitHub, so hopefully you should be able to check it out at home in Visual Studio, and that's the starting point for today's lesson. So we try and remind ourselves what we're hoping to achieve. Yeah, I'll check it out on the C drive. You shouldn't do that at school, but if you're at school, you've got it on the W drive already. We're trying to make something where you've got a grid on your screen using a graphical interface, using WinForms in C#, and you can click on each of the squares to toggle whether that square is something you can walk through or whether it's an obstacle, so that we can then implement an algorithm to find our way from any one point to any other point. So it's a problem that is solvable using different algorithms, and we can look at whether we can use heuristics or backtracking or visualization, decomposition, abstraction. We can apply all of those concepts to a real-world solution. So will it work if I check it out? Yeah, here's what we managed to get last lesson. We have a WinForms graphical user interface. You can choose the size of the grid. I didn't actually test to see if it works, but if we go 20 by 20 and generate the grid, then we have a grid here. And we have a little status bar down at the bottom. It doesn't automatically scale properly, so maybe we should fix that first. It's just drawn it once and then repeated our grid all the way across. So let's have a look and see what the code is so far. We have a button that puts a little status message on here. We have a tab control so that we can have all of our controls for the settings in one space and the drawings in somewhere else. We've got some defaults. We've got some, this is checking to see if the user has typed in something sensible that we can convert to an integer. And this will actually draw the grid. So we want an event-driven graphical user interface. So we're not just having a program in console that runs from start to finish. It's event-driven. So when the user does something, your program responds. So let's see what events we can respond to. If we go to Properties with the form selected, let's just dock that so it doesn't hide when I click off it. We should be able to see, number one, all of the properties, but number two, all of the events that we can respond to. So think of like a lightning strike as an event that you'd probably want to run away from. We can define behavior to all of these events too, like resize. Is it form resize, form closing, or is it just resize? There we go. If I double click in here, it will add an event handler. So we can say what happens. Well, what do I want to happen? All I want to do is just call this method that we defined last lesson, draw a grid based on X and Y size. So let's draw the grid, but it doesn't have a method implementation that doesn't have any parameters. We need to specify the X and the Y, in which case we should probably try and remember what the previous values were. Help. Or we could just copy and paste all of this, which might be easier for now. Probably be better if we try and remember what the previous values were, but let's keep things simple and just copy and paste all of that. All right, let's see if it works now. Hopefully, every time you resize the form, it will redraw the grid. Let's see. We redraw it. Yeah, it's drawn it 10 by 10. It's working. Or if we go for 10 by 100, let's see. Yeah, it's kind of working. So what I'd like to happen next is to allow us to be able to click on each of these and toggle between, say, green and white, so that we can see whether or not they are an obstacle or not. So that's what the behavior that I want, but we need to start thinking in terms of data structures. We need to decompose it and split it down into different parts. Here we go. So I think it's always helpful to step through the thought processes behind here. It should be easy enough for us to be able to make it so you click on something and it changes color, but in order for us to make it work properly, we should think about all of the parts involved and how we store that and represent it in memory first. So we're not going to rush through, we're going to do this properly. I want to insert a smart art. Come on, Word. There we go, smart art. And we will do a hierarchy, something that we can use for decomposition. So let's go find the way, and we're going to decompose that into, I don't know, the graphical user interface. And the GUI needs to have settings, and we need to be able to display the grid. But we've also got the data structures behind it. So how are we going to actually store this? Well, we need to store the obstacles for the grid. And so I guess each square should be an obstacle or something that we can walk through. We need to describe the grid of the obstacles, and we need to describe a route. So we're going to decompose this so we can do each task separately. A smaller problem is easier to solve than a bigger problem. It's also quite nice because we've done part of this already. We've done the bits for the graphical user interface. What we haven't yet done is any of the data structures work. So let's define what we mean by a square. And we're going to do this as a class. So you might want to draw a class diagram first, or launch straight into making the class. Let's make a class. So right click on your project and add a class. And we'll call it grid square. Something that you can click on, and also something that you can use in your route. So let's think what the grid square should be. We need to find out probably its position. So how do we define its position? Well, it's going to have an x coordinate and a y coordinate. Let's make them public. Int x, public int y. We should store whether or not you can walk through it. So let's have a boolean, bool obstacle. And I suppose we could store whether or not it's the start point or the end point, couldn't we? Because then we can use this when we're displaying it. So we set up our data structure to store all of these together. Wouldn't it be nice if we had a constructor so that we could instantly define all of these? So let's make one. Inside the class, we could have a public method which creates a new grid square. When we make a new grid square, we're going to assume that it's not an obstacle, that it's not a start point and it's not an end point, but we want to know the x and the y coordinates. So we can say this.x, so the attribute value for the class is going to be equal to the parameter value passed into the constructor. And the attribute value for this instance of the class is going to be set to the parameter value passed into the constructor. And then we just assume that obstacle is set to false. Start point is set to false. And end point is set to false. Which is okay, but wouldn't it be nice if you could specify them optionally? So we can say bools obstacle equals and set a default value in here. More logical, perhaps, if we do it the other way, if we say the start point first. So here we go, this.obstacle is equal to obstacle. This.start point, that's the attribute value, we're going to set that to the parameter value. And I do like how Visual Studio grayed that out, because we were setting the parameter value, which is pointless really, because that parameter value is going to disappear as soon as the constructor finishes running. So what do these actually mean? Well, let's comment it. Let's put our 3 forward slashes and describe what this does. Create a new grid square. And we can have the x coordinate, the y coordinate, And then we describe what each of these parameters mean. So true if this grid square is an obstacle, or false if you can walk through it. True if this is the start of the route. True if this is the end of the route. All right, so let's use this. For now, I'm just going to go inside the btn generate thing so that when we generate a new grid, I would like to attempt to make those grid squares as well. So here we go. If we manage to succeed in getting the values, oh no, even though, yeah, so it's going to be down here. Either we can read them from the text boxes or we use the defaults, doesn't really matter, but after that point we know how many we've got. So we want to make one grid square, we just call the constructor. We can say we're going to make an object of type grid square. So grid square is a class, let's just call it square, that's going to be an object. We'll call the constructor, and then we get access to all of that self-documenting stuff that we wrote in the other class. We want to create a new grid square, and notice the two parameters that are compulsory we have to type in. So I'm going to make one at 0, 0, and these are optional. I don't need to provide them. It tells us what the defaults are, but I don't need to bother providing them here. If we want to go for the defaults, I can put them in either by order, or I can say endpoint is equal to true. I think we can do that. Will that work? I don't know the syntax in C#. Maybe you have to say them all. But if I just want to say them at one particular position, we can just call the constructor and leave the optional parameters, sorry, the optional arguments. We're passing them in at this point. So they're arguments as blank. What I'd really like to do is make all of them. So let's use some iteration. For int, now we can't use x because we used that to define this here. So I suppose we could use xpos, or I probably should have set these to x size and y size. So I'm going to iterate through all values of xpos, and I want to have a nested loop to do the same for all values of ypos. Start from 0. And we'll increment through each one. Then we can make a new instance of the grid square class at that position. So we've got a decision at this point. We've made an instance, but we want to store them somewhere. We need to think about a data structure that can store lots of values. It could be a one-dimensional array. It could be a one-dimensional list. Perhaps it would make more sense if it was 2 dimensions because we've got x and y to deal with. It doesn't have to be, but it would perhaps make more sense if it was. So we would like an array. We would like an array of grid squares. So grid square. And it's going to have to be 2-dimensional. So is that how we do it in C#? I can't remember. Let's give it a name. Grid. And then we need to define the size of it. Can we do it like this? I don't know. I'm probably going to get this horribly wrong and have to search for the syntax. But it needs to be that big for x and that big for y. Will that work? Probably not. So we have to do a little bit of Googling and collaborate for the syntax to create this 2-dimensional array. So this is the data type. Remember, an array is a static data structure that will store multiple values of the same data types. They all have to be the same data type. We've got 2 dimensions, 2 indexing expressions, x and y. That's what we're going to call it. And we make it this size, x and y. This isn't actually a very good way of creating it, because this is going to be a local variable that only exists within the scope of btn generate click. So as soon as you finish clicking that button, all of the items that you've stored in that grid are going to disappear. So we need to make sure that that is an attribute that belongs to the class, a bit like a global variable, rather than a local variable. That does mean that we can't call the constructor yet, but we can just say that it exists. But we can still make the new thing and initialize all the values here. So we want to do that before we iterate through all of the x and y positions, and then store this in the right place. So let's see, grid square brackets x pos y pos is equal to the new value that we've just, the new instance of the square grid square class that we've just made. So I'm going to put a breakpoint on down here to see if it actually works, see if it crashes and see if it works. So breakpoint, remember, just means that the program will pause when we get to that point. So we can see our data structure. Let's see. I'll generate a grid. It should do all of that. It gets to this position here, and I'll hover my mouse over grids, and hopefully we will have all of these things. So we can see the first value at 0, 0, x is 0, y is 0, good. This one down here, good, x is 0, but y is 8. And we should have 100 of them, where end point, obstacle, and start point are all set to false, but the x and y coordinates are all set in there. So at this point, we can adapt our DrawGrid method so that it doesn't just always draw it in red, it will draw it in different colors depending on whether or not it's an obstacle or a start point or an end point. So you can make some choices here. Let's see. What did we call the class? Grid square. Let's call it square. Let's access the items from the grids. So let's pass in the x coordinate and the y coordinate. And then we should be able to see now whether or not it is an obstacle, whether or not it's a start point, and whether or not it's an end point. So I've only used one pen so far, so let's define a couple of others. So let's assume that the normal thing is just red. So let's call it pen normal. We can have pen obstacle with a different color. So I'm going to say the normal one is blue. An obstacle is going to be red. Start needs to be green. I don't know. You can choose your own color scheme. Remember, we want to have a route from one square to another square. That's what we're trying to aim for. We should probably have a little key on there to make this easier to understand, but those are the colors I'm going to go for. So let's see, pen, pen, and we'll assume it's the normal pen to begin with. But if our square, square, if it's an obstacle, then we're going to set our pen to point to the obstacle pen. We should probably comment it. An obstacle, obstacle. Right, let's do the same for... now it's probably a bad idea to put the actual colours in comments. Let's just see, change colour, because you might decide to change the colour up here but forget to change your comments. So what have we got? Change the colour for the start. So if it's the start point, then we're going to use the pen for the start position. And if it's the end point, then we'll set the pen to the end point. Okay, so when we actually run it, I don't expect it to do anything different at the moment because they are all just set to normal. So we have some undefined behavior at the moment, because what happens if it's an obstacle and it's the start point? Well, realistically, that shouldn't happen, should it? Because you shouldn't have an obstacle at the point where you're starting at. But perhaps we should redefine our class to make it impossible for that to be represented in our data structure. But I'm not going to bother doing that just yet. Our next stage is to make it so that you can toggle by clicking. So if you click on one of these, it makes it either an obstacle or not an obstacle, and then it updates the grid. So good. So our next stage is to make it so that when we click on each one of these, it will toggle the color, as in it will make it so that it's an obstacle or it's not an obstacle. So I think actually, first step, I just want to make it so that when I move my mouse over it, it tells me where I am in the grid and whether it's an obstacle or not an obstacle. So let's add an event handler. If we click on the thing we want to respond, so that's the panel on your visualization tab, let's find the events, and I'll go for a mouse move event in here. Double click on that, and we should have an event now every time the mouse moves. We've just added an event handler so that every time you move the mouse, this gets called. And we have some parameters passed here. So a mouse event arg, so we can do e.x and e.y. Remember, we made a little status thing down here called lbl status. So if we do lbl status dot text is equal to, and then we set up a interpolated string, says mouse moved to, and then let's put the coordinates in, e.x and e.y, just to see what's happening. I think this is capital letters in here. So remember, this is event driven. Whenever an event is triggered, whenever an event happens, we've told our code to respond by running that code. So now whenever you move your mouse, you can see the coordinates here, but that's actual coordinates for this control. We want to translate that into grid coordinates, as in 0, 0, 1, 0, 2, 0, rather than the actual pixel coordinates. So let's see if we can do some translation. We could do it in here, but it's probably something we're going to need to use repeatedly. So why don't we make a method that does it? So what do we want to do? We want to get an x and a y position. Is there a structure called a point that has x and y? Yeah, there is. That's nice. Let's go screen to grid coordinates. We need to specify the screen x and the screen y. I want to make a new point, data structure. And we want to return it. So how can we do the translations here? Well, we need to know the x and y dimensions of our grid. So at this point, we should probably remember the values that we've specified here, or we can get them from our grid data structure, because we know that the grid dot length, that is going to be the amount of x, because we've got a two-dimensional array, and the first indexing expression in that will be the amount of x coordinates. So let's see, int grid x should be, and I'm probably going to do this the wrong way around, but we'll see, grid dot length. Right, how do we get the second bounds? We get the first value. Sorry, let's make it a lot simpler, and let's make a kind of global attribute for the grid X and the grid Y. So int grid size. Do you know what? We could make it a point, couldn't we? A point is something that has X and Y. So that when we when we initialize the values to store all of those things, where do we do that? Here, grid equals new grid square X and Y. We can say the grid size dot X is going to be the X dimensions, and the grid size dot Y is going to be the Y dimensions. That's better. Which actually is going to simplify things a little bit, because if you remember when we had our resize thing, we had to work out all of these coordinates again. We can now simplify that much more. I said back then we should have done this. We can say grid size dot X and grid size dot Y, which should hopefully work better. Okay, we haven't done our translation yet, so I'm going to pause the video and see if you can work out what maths you need to do to be able to go from the actual physical size to the grid size. But let's just check and see if it works so far, and I'll pause to give you a chance to catch up and we can do some collaborative debugging. Let's see. Does it work? Yeah, hopefully so far. So that's as far as we can get today. Your challenge, if you're up for it, is to pull this latest version from GitHub and then implement this method. You get some pixel coordinates in. I want to get grid coordinates out. So all you've got to do is just divide these by the width of each grid square or grid rectangle and return it as a point object. And we'll pick up the pieces and try and implement the pathfinding algorithms next time.